G'day, Michael here. I did something yesterday which quite surprised me. I was able to change a 8TB RAID 0 array of 2 disks, so it's two 4TB drives, from making an 8TB RAID 0 array, converting it midstream to a RAID 1, so you had mirrored drives. There was already 2TB of data on the array. I was also ripping DVDs at the time. I was able to convert the 2 drives on the fly to a single RAID 1 from it being a RAID 0 while I was ripping DVDs using Btrfs. Now, I was absolutely flabbergasted by how well it was performing. It's on a different machine, but well, a different machine to this one physically, but it's the same style of machine. Basically, it's a dual Xeon T5500, and I find them very useful. As an old machine, they actually have a lot of abilities. Anywho, so what I'm going to do is do a mock-up of what I did, just to show how simple it actually is. Now, I'll probably end up cutting a lot of this out because you have to wait for things. But in any case, here I am in. I'm going to use a virtual machine, so I'm using Oracle's VirtualBox, and I'm going to create under Ubuntu 16, which is something I haven't used since a couple of days ago. Alright, so I'm just going to create 2 small drives, which I'll make them a RAID 0, so it ends up being double size. I'll show you what I mean. There we go. Get rolling. So pre-allocate full size. This is all on a Btrfs file system underneath, even in the virtual environment, so it's a good idea to pre-allocate. Now, there's only a demo. I'm going to change that to, where are we, virtual machines, Ubuntu 16, that'll do. I'm going to call it RAID A, video, that'll do. Finish. Create a new one. Like I said, it doesn't really matter to me how big it is. Keeps going to Sierra for some reason. Right, where are we? Pick that name and change it to B. Save. Okay, finish. Right, now let's go into the configuration of this guy. Oh no, there we go. 16. Settings. Storage, add controller, add attachment. Okay. Hard disk. That one. Choose. Hard disk. RAID B. Choose. Okay, that should do it. Let's spin that up. Right, so let's open a terminal. And what we'll do is get on as administrator. Okay, ls. Actually, I might ls blk. See what block devices we have, and we should have SDB and SDC are our two 2GB disks, right? So I'm going to make Btrfs file systems on both those. So make fs.btrfs dev sdb. We don't need data partition. Btrfs will just use the whole drive. Oh, we don't have it installed, so okay. Apt install Btrfs progs. There we go. That took a minute or two. Now, go back to make Btrfs file system. That's been done. And the other one was SDC. I'll just relist that. LS BLK SDC, right. Right, so let's, it doesn't matter where you mount them. I normally mount like a large array as its own directory on the root file system as storage. So I go make dir storage, and then what we can do is, if you want to put it somewhere else, do that. You can make a directory under the MNT directory, wherever you want to put it. That's up to you. Now, if you want to include in the FS tab file, it may be better to use, rather than like dev SDC and dev SDB, to use the block ID. So blk ID dev SDB, and as you can see, this device ID here is how that works. Actually, I'll do that, so I'll show you how that's done. So I'm going to go copy. Hopefully I've got Joe installed, etc fs tab. Okay, so you can see instances are already up here in the same format. That's a swap. Okay, so we go UU ID, oopsie, UU ID equals, paste that one. We're going to go storage. Btrfs. I'm just going to go defaults. Control K X. Mount -A. DF. You can see storage has been mounted. It's showing there's 2 gigabytes. It's got some usage, and that's the amount of free space available. So it's got 1% usage nominally. Okay, so just check my notes here. What we can do now is Btrfs space device space add SDC, because we've got SDB up already, SDC, on that same folder, storage. -F. So what we're doing here is using the Btrfs utility command to device add, or add a device, right? Device is SDC, whereas we had SDB already mounted. So it's going to add SDC to SDB to that folder storage, and I can't remember what the F stands for, so let me just follow that up. So don't know what the F stands for just yet. Okay. So if we're at DF now, storage has grown to now 4 gigabytes. So before it was 2 gigabytes. Now it's 4 gigabytes. So that's actually a RAID level 0. So it's put the 2 drives together and made a double size drive. So let's just have a look at what that gives us. Go back to file system. The user Michael may not be able to access it. Can we create something? No, we can't create anything. Okay, so I'm going to make it so Michael owns this. So CHOWN -R, just in case there's subdirectories. User is Michael. This is up to you which permissions you have to. This not the scope of this video, but you may want to have a group, say Michael and users, and you have a number of different users that are available, able to use that drive, but they're in the group users, etc. I'm just making it owned by Michael and in the group Michael. So now Michael, with a bit of luck, should be able to create a new folder, and he can. New folder. It's a good idea to use underscores instead of spaces in all your file names. That way, if you do end up using a script somewhere, it's a lot easier to manage the spaces. Spaces can be assumed as like a change of instruction, whereas an underscore is a continuation of the same name. All right. So what have I got here? Let's just copy a few files, maybe that one. I'll copy this to there. That should be pretty much done, I would expect. Yep. So we've now got, going to our terminal, let's just see how free that is. CD storage. So we've got those two, or a folder and a file on that storage directory, as you can see in the graphical environment. It says free space 4 gigabytes. So if I go DU here, it's using, what's that, about 78 megabytes odd. So that shows we've got something on that drive. But we can actually convert that on the fly while it's even being written to. I don't have a big enough file to get it busy to demonstrate that. But the Btrfs space balance space start space deconvert. So we're going to convert it equals to a RAID 1. Mconvert equals RAID 1. Now the -D stands for data blocks convert to RAID 1, and the -M stands for metadata convert to RAID 1. And which device, well, it's not really a device, what are we calling it? Storage. Okay, so now what that will do, now just to refresh our memory, it's only showing as SDB is mounted, but we've got 4 gigabytes, right? So after this we should have 2 gigabytes, and obviously this won't change, or shouldn't change much, and that will change dramatically, and that should sort of double its apparent value. Right, shouldn't take long. Okay, so if I go DF, so now we've got 2 gigabytes and it's about 5% usage. So just like that, we've converted it from RAID 0 to RAID 1. Let's see what actually is going on behind the scenes in the Btrfs world. Btrfs file system, I think it's show, let's check that. There we go. So we've got, this is showing us that the device, you might remember that number from the number I copied and pasted into the etc fs tab file, which is the file system table. Right, now it's got dev ID 1 is 2 gigabytes. Thank you. 2 gigabytes. It's called dev SDB, and another one 2 gigabytes SDC. They're combined to make a total of, looking at that, the 2 gigabytes. So we've got two 2 gigabyte drives, and they add up to 2 gigabytes, but you have the redundancy. If one of those drives failed, the other drive has, well, they're both got the same data on. Now, what's the advantage of using something like Btrfs, or what's another one, ZFS, versus using a hardware RAID? Well, both the file system based RAID arrangements are capable of putting blocks in different places on the drive, whereas a hardware RAID requires both drives to have an absolute mirror. Every block is the same on both drives. So if there is a defect on the drive, the file system can work around it. The other thing that happens with both Btrfs and ZFS is they have a checksum of the blocks, so that if one of the blocks that's a copy somehow is corrupted, say with a bit rot or some wear on the drive, it's able to, on reading, say, hey, there's something wrong with this block, it doesn't add up with a checksum. It can discard that block, get the good block off the other drive, write a new block somewhere on the drive, thus working around wear and tear on the drive, and also working around bit rot. Basically, to protect against bit rot, all you need to do is copy the files off and on the drive every so often. Even just reading them means the file system is alert to any defects. A drive turned off and shoved in the cupboard somewhere for 10 years will lose data. But if it's somewhat active, if you can get it to read from one drive to another drive every couple of years, you're refreshing for bit rot. So if you've got otherwise a drive that's not wearing very much, just copying on and off will refresh the data. I hope that was of interest to you, of use to you, some sort of entertainment value. If it was any of those things, feel free to like, share, subscribe, ask a question, leave a comment. Bye for now.